Yeah, good evening. My name is Evans Okoli. So, this is a weekly recap of what we did at the program, the blockchain development program at the Web3 Bridge facility here in Lagos. So, last week we were taught about smart contract development, specifically Solidity, how to, the basics of how to create a smart contract using Solidity. So first of all, a smart contract is a code that lives on the blockchain or on any network that self-executes itself when a predefined conditions is met. So you have a contract. It's just a code, a coded contract that's deployed to a network, and then when a particular condition is met, the contract executes itself. Okay, for instance, maybe your landlord may have a smart contract that people use to pay rent. So what will happen is at the expiration of your tenure, the the smart contract may automatically sign you out. You know, it will terminate the kind of maybe the receipt given to you when you paid for your annual rent. So when you now pay the new rent, the smart contract will automatically generate a receipt for you, and then add go to the maybe a database or something and add to that database that you have paid for another year. So it's a kind of normal traditional contract that is written in offices, maybe in the chambers, lawyers' chambers or anything. But then this one is living on a network, specifically on the blockchain network. So what we have is I write this contract, I deploy it to a network. Anything I write within it, maybe people can write a contract. There's this simple banking system now. You just write a contract where people can deposit money and withdraw money. Just deposit Ether or any cryptocurrency. Where you want to withdraw. All these dApps you are seeing, maybe these staking platforms and all these things, most of them are being powered by smart contracts. So that's just the basics of what a smart contract is. So now go to Solidity. Solidity is a programming language for writing smart contract. So it's more like TypeScript. So you know TypeScript is JavaScript. That's just it has types defined. So Solidity is just JavaScript with types that the types are defined, statically defined. So that's why they said that Solidity is a statically typed language, programming language. So although there are some features that it has, like mapping, struct, enums, and the others. Then also you have this what they call ABI code and bytecode. When you compile a Solidity contract, when it's compiled, it will give out two, do I call it codes? Two outputs in form of codes anyway. It's a kind of code. The ABI code and the bytecode. ABI code means application binary interface. So it's a list of all the functions, state mutability, and the visibility of all the functions and parameters in the contract. Then bytecode is an EVM language. Let me just say it's an EVM code. Only a table virtual machine can understand what a bytecode is. So if you look at it, it's just random numbers, random numbers from beginning to end. But all of them, the EVM understands what they mean. So they convert the bytecodes to opcode and all these things in the background. Then we have okay. There are other few features of Solidity, like maybe when you have storage and memory and all data. Then storage, when you want to save a state variable, is saved in the storage. So that one is permanently stored on the blockchain. Then you have your memory. Memory storage is just temporary. It's something you can just maybe you want to run a computation, just finish it and wipe that one out. So that's what memory does. It's also the same with core data too. That are read only. You cannot change. It doesn't hold it doesn't hold data permanently. It's just what you just hold data for a particular period of time that is needed. After then, everything wipes off again. So that's it. And that. Then I also have types of functions you have in Solidity. You have payable functions and non-payable functions. Payable functions are the one that can accept payment. That's just the clear cut distinction. Payable functions accept payment. Non-payable functions do not accept payment. You cannot send data to a non-payable function. Yeah. So then we have there's the kind of variables we have in Solidity. You have global variable, you have state variable, and local variable. So global variables, they are just already defined by the Solidity language. Sorry. Then state variables, the developer defines the state variable, but then they have global scope within the contract, and they are stored in the storage. Then we have local variable. Local variable are just like they have local scope, what they call scope in JavaScript and other languages. You just local to a particular function. You cannot access it outside that function. So that's what local variable is. So we have what they call state mutability in Solidity. It has to do with how you access a variable, how you access maybe a state variable or a data type or anything. So we have view and pure. So view functions, when you declare a function as view, it can only read. It can read from a variable, but it cannot change the variable. It cannot maybe change the value of that variable. So view is read only. Maybe you have a variable like a is equal to 10. What a view function will do is just to capture that value, that 10, and return in the function. It cannot change the 10. It cannot change that 10 to maybe 11 or 12. So that's it. But pure functions cannot read or write to any variable. So it only does a local computation in that function and return the value back to you. That's the difference. Then have also function visibility and state variable visibility. Function visibility is, when you talk about function visibility, is like where the function can be called from, not particularly in terms of location, but within the network, within the contract, and also within the AVM network. Because you find out that a contract can be called from anywhere. So it's now the visibility of the function that we now specify where the function can be called from. So we have private functions. Private functions can only be called within the contract. You cannot call it outside that contract. Even if it's inherited contract, it will not go. Then you have internal functions that you can also call it from an inherited contract. Then you have external function that you can only call it from outside the contract, unless if you want to call it within the contract, you will call it using this, right? This dot that function. Then you have public function that can call from within the contract and outside the contract. So that's basically it. So I won't go into talking about how to create a contract because of time. So I'm going to end yeah, for this week. So, but expect another video by next week because this is a weekly duty kind of. So at the end of every week, I have to come and present what I want for that week. So that's why we are. That's why I'm doing this. So expect me again next week. From here is good. Thank you for watching.